I'm CK. Tonight we're going to do another eurorack module. This one is from Patching Panda, and this is their Punch, and this is version 3 of that unit. It's a voltage control amplifier and decay unit. Looks kind of fun. It's optimized for percussive stuff, but they also say you can use it for bass lines and leads, and we'll see what that sounds like. Looking forward to it. Here we go. Here's the package. I ordered this from Thonk out of the UK as usual. I actually, over time, I've used other eurorack shops, but I continue to find Thonk to be the best. They suit me the best. So, it's from Patching Panda out of Barcelona. Typical, and again, this is very similar to all Thonk kits. The support URL, the fact that this one's a black faceplate, because that's what I ordered. Let's see what we got in the bag. We've got a bag in the bag. And this will be the front panel and circuit board, very likely. In fact, if it isn't, I'll be very surprised. Oh, and of course, another sticker for the Patching Panda. Go on my sticker wall. Please refer to the patchingpanda.com to assemble this module. Thank you for adopting a panda in your rack. Here's the front panel with the outs and the envelopes, trigger, control voltage, a bunch of other things. I think 2 LEDs go here. A bunch of knobs and patches. Here's the front of the circuit board. Here's the back. It's already pre-populated with quite a few surface mount components. There's 1, 2, 3, 4, 5, 6, 7, 8 ICs, some CAN electrolytic capacitors, then a whole bunch of transistors, resistors, capacitors, and so on. So a lot of it is already built. Interesting that it says Punch version 2.8 on the board and 3.0 on the box. So I'm assuming the 3.0 is more about the software burnt into the chips than it is the layout of the board. So let's see what we're going to be putting together. Cable. I'm just going to dump this all out because it looks pretty similar. It looks like we're mainly putting knobs and jacks on the board. Yeah. One pin header. 1, 2 LEDs. But the rest of it is knobs and jacks. So with that in mind, let's take a look at the instructions to see if there's anything particularly unusual here. Because at this point it doesn't look that way. Looks like they've got some demo YouTube videos, which is always nice. You can offer the full surface mount kit if you want. I did not know that. Thonk didn't list that, or I didn't notice it. I'm not sure I would have bought it anyway, because that's a whole whole bunch of little resistors. But other than that, looks pretty straightforward and simple. So I'm going to drop this into fast motion and just put this all together, and then we'll put it in the rack and see how it performs. So I'm going to pause the cameras for a minute while I get set up to do that. Okay, I'm going to pause and talk a little bit. I didn't think I was going to be, but this power stack connector coming in kind of interferes with that jack. But this is definitely, as you can see right here, that's definitely where the eurorack power cable goes. But I don't know how I'm going to get that. See, these pins are right against that jack. I don't know how it's going to sit flat once I've soldered the jack in. So instead of continuing to put the jacks on and then put the panel on, then do leveling and facing like we usually do for eurorack, I'm going to put this connector in first. I may even, see, I was going to solder it on the other side because these are full plated through hole pins. It's a good circuit board. I think but they're so close to that capacitor. Huh. Well, let me see how it goes. So we're all set up, and as you might have noticed, even though you probably didn't, these three jacks are higher by about 1/32 of an inch than everything else, because they're sitting on top of the pins for the power connector. Again, I think that's a bad idea. As we know, distances between the circuit board and the front panel are defined in eurorack by the height of the tallest component. By having the tallest component here be these three jacks being taller than these, it's just going to be kind of a weird layout, because I'm going to be soldering, because they're the highest, so again they set the height of the distance between the circuit board and the front panel, but only by a little bit, and then I'm going to have to draw out envelope 1, envelope 2, trigger CV, accent and velocity all up a little bit off the board. The other thing I'm not quite sure about is how we're going to do with a tilt this way. So see back here, let me change it to something other people could understand. This is defined height. I can't change this unless I grind those connectors off, and I don't want to do that. And that is 10.36 millimeters. So to be parallel, oops, let me try and stretch it out to, let me get that again, because of course I forgot what it was already. Okay, we'll call it 10.4. So if I go down to 10.4 on that side, I mean, I don't have any threads to grip. I don't get threads. I don't get like a single thread until 9.4, that's a full millimeter slope. It just, I mean, it's not a big deal. It's not going to hurt functionality. It kind of, for lack of a better term, offends my engineering sensibilities. I want it to be, I want the circuit board to be parallel to the front panel, and I'm not able to get that. I think, had we been able to not have this power connector interfering with those jacks, I think we would have gotten that. I mean, again, the potentiometers aren't tall enough. Let me be articulate. I can't raise them enough to get enough threads to tighten them. So they're not going to have panel nuts on them. I don't necessarily like to be fussing with this much, but I want it all to sit right. I think I can get threads on all the jacks, which in the end is probably all I really care about. But if you're building this yourself, it's a little wacky. So what I'm going to have to do to get my 10.4 here is I'm going to have to use this Decay jack as the foundational piece for setting that height. Okay, that'll be okay, and I may be able to get a little bit of thread on the rheostats potentiometers, but I'm actually not even going to try. The only thing I have to worry about now is these switches to get the now I've got at least a little of the support tang coming through the hole so I can solder it. So that's good. I think it'll, again, it's functional. It's just a little, you can't secure it really well. You can't put panel nuts on these potentiometers. That's just the reality of it. No way can you you can't draw the panel any further down because you're on top of the jack, and you can't pull the rheostats further up or else they're out of their pins on the motherboard, and that's the worst thing. So we just have to deal with it the way it is. Okay, so I'm going to go ahead and solder all the components and put the little LED eyes in. So we'll go back to fast motion, no commentary for that. Okay, there she is all together. And I do want to also mention that this parallelism that I'm obsessing about, and the fact that I can't actually get any threads of the potentiometers to come through the front panel, may not actually be anything that Patching Panda has done. The people who assembled this kit and the suppliers of the pots may have changed. Who knows? There's lots of things. I'm not going to ding them on that. Now let's do a quick check of, make sure everything works, at least mechanically. Okay, jacks all feel good. Switches feel good. Before I put this in my rack, I'm going to do one other thing. I'm just going to do a quick smoke test on the workbench before I put it in the rack. This is a Frequency Central Routemaster. That's what I use for power all the time. I have a build video of putting this unit together that you can see on this very same YouTube channel. I'll have a link in the description below. Plug in the cable and make sure we've got polarity correct, which we do. Red stripe, -12. Let's whack this in and see if we get any magic smoke. Okay, we're not getting any smoke. Of course, we don't get any lights because we don't have any trigger coming in. Let me do a quick couple of probes here and there. Getting good readings. At various parts around the board. Okay, so should be ready to put it in the rack, and we'll give her a spin. So we've got her plugged into the rack, the shop rack. Using Frequency Central, Routemaster power supply, Befaco Midi Thing, Duskwork VCO, and Befaco ADSR, and a Befaco output, which is powering a little 15-watt guitar amp I have down here on the floor. So let's do the basics, which is simply coming from the gate of the MIDI thing into the trigger, and let me make sure that it's set for trigger. Now it's set for trigger, and the CV from the MIDI thing is gone to the oscillator, and the ADSR is out of the picture for right now, and the out is putting out to the speaker. So you can see I've got everything turned down, and all we're getting is little chirps. Now if I start opening things up, we get more input until it sounds almost normal. And that's very good percussive stuff. Now we'll go ahead and swap the trigger for the ADSR. So we'll do CV into there, and then the output from the ADSR into here, and switch to CV mode. So it acts like you would expect. We can do other things, and I don't have it configured this way right now, to add the AM modulation and other things. But basically, it works the way you would expect. Let's see if we switch this back to trigger. It's working fine, and with the addition, I mean, doing the percussive stuff is really probably the most important for this unit. So this is a useful little unit, a very simple build. Obviously, since it's mostly surface mount and that came pre-installed. The only challenge being getting the front panel aligned properly, and that was a bit of a pain. Where that, where the power connector is a really bad design decision, and they should revisit that, look around that to make sure that all the jacks are on the same horizontal plane. But other than that, it's fine. Hope you enjoyed it.